Finally, I will introduce the Hartree and Hartree Fock equation, and it is a basic fundamental equation to calculate the many electron system. And Hartree and Hartree Fock equation. It is the equation for many electron system. Basic principle for the exchange interaction, like double exchange, direct exchange, super exchange interaction, and DM interaction, IKKY interaction. Basic interaction can be calculated from the quantum mechanical Schrödinger equation. Therefore, the simple problem is the Hartree equation, like this. As we discussed before, and the Coulomb interaction is very important because in electrons, then Coulomb energy is important interaction energy. And also, Hartree equation do not consider for the spin interaction. And let's consider for the one electron Schrödinger equation. One electron Schrödinger equation is simply write down as h bar square over 2m del square of psi r plus ur psi r equal epsilon psi r. It is a one electron Schrödinger equation, but n particle system, n number of particle system, the Hamiltonian eigenvalue problem can be written down like this. The capital psi means that the total wave function, and because there are n number of electrons, summation for n minus h bar square over 2m del I square. Del I means that for individual electronic, and the psi total wave function, and here minus ge square summation for r minus r. In the solid state physics, in the first chapter in many solid state textbook, there is a concept for the reciprocal lattice and crystal structure, and here R is that the reciprocal lattice, and the reciprocal lattice R is that the position of Rabi's lattice, and Rabi's lattice is a unit cell lattice on the like cubic structure, orthorhombic structure, tetragonal, and so many crystal structure, and that we call it, that is Rabi's lattice, and Rabi's lattice summation with respect to the Rabi's lattice, and GE means that this term is coming from the interaction between nuclei and electron. Interaction between electron and nuclei, and also plus 1/2 summation for I not j. It is in other words, it is that ij summation ij or so, and here electron interaction Ri minus Rj E square psi equal to E psi, and it is the electron interaction. electrons. Here, the I should not be J because we should exclude the self-interaction and the one half coming from the double counting. Exclude the double counting. Therefore, let's separate the potential of ions. U ionic potential is that minus GE square with respect to the Bravais lattice, R minus R, and electric potential can be written down because in theory the electron can be considered as particle, but in realistic there are so many electrons that therefore electron can consider as a distribution of charged particles, distribution of charge in the state. Therefore we can think about that the charge density in the minus E integral dr prime, and we can consider as a charged particle, charge density distribution. And here the electron charge density rho r is that minus E psi I r square in other words, summation is omitted. Summation for I minus E. It is electronic charge density. Therefore, when we write down this equation, then let's write down this Schrödinger equation. And this Schrödinger equation for can be write down H basicule 2m plus electron ion interaction plus summation for J, because in this case we only consider for the I state, we only consider for the ith atom, ith electron, therefore we do not consider for the ij summation but only j summation. And multiply okay, and this term is the first term is kinetic energy. It is kinetic energy, and second one is that electron ion interaction, and this third term from here to here, this third term is the electron interaction. Here we should note that psi I is that what we are interested electronic wave function. But here, in order to calculate, the psi j is the other electronic site, the other electronic interacting counterpart electronic wave function. Therefore, how to calculate this one? It is very nervous, and because it is we call it is an iterative method, we can solve the Hartree equation, and it is an iterative method. And suppose that we know that psi j, but actually we do not know exactly, but let's suppose that we roughly know that the psi j, then insert psi j, we can calculate exactly by the eigenvalue problem. Then the eigenfunction psi I can be identified, and this psi I insert again as a psi j, and so many iterative calculation can converge in a certain wave function. Then if the wave function is converges, then we can say that it is close to the real eigenfunction, and therefore let's suppose that let's make a trial wave function. Psi j. Actually, we do not know that wave function, but roughly assume that the wave function, we call it is a trial wave function, and substitute a trial wave function in the psi j, and we can solve the this Schrödinger equation, otherwise Hartree equation. Then the resulting wave function is that psi I, because psi j is the parameter. We use psi j as a parameter, and from this equation we can solve the eigenstate as a psi I and eigenvalue epsilon I. Then this psi I should be replaced as by psi j also, and solve again. Iteration. We call it is an iteration method, and it is an iteration method. And psi I substitute as a psi j. Then also solve the problem like second. Then like this, and iterative solution until psi converge. And it is a Hartree method, and this iteration can be possible in computation because nowadays many physical problems can be solved by the numerical method by the computer, and the computing system can solve very well, very effectively this kind of iteration method. And anyway, this Hartree equation does not take into account the exchange interaction, but we should consider for the exchange interaction like Heisenberg exchange principle, Heisenberg exchange energy. The modified Hartree equation is that the Hartree Fock equation. And basically, Hartree equation doesn't consider the exchange interaction. Therefore, in order to include the antisymmetric wave function by Pauli exclusion principle, the trial wave function should have the Slate determinant form, and also antisymmetric wave function by Pauli exclusion principle. Anyway, the Heisenberg equation, Heisenberg Hamiltonian, also coming from the Pauli exclusion principle, and it is the identical result. then the trial wave function may have this kind of value. Here is that R1 is a special part, S1 is the spin, R2, S2, and n number of electrons, Rn, Sn. Then we call it is a Slate determinant. Psi, capital psi is that the total wave function, and small psi is that single electronic wave function. R1, S1, psi 1, R2, S2, like psi 1, Rn, Sn. One electron may have the different site and a different spin. In the two electrons, second electrons, R1, S1, psi 2, R2, S2, like this, psi 2, Rn, Sn, and like this, like this, like this, psi n, R1, S1, psi 2, psi n, psi n, R2, S2, psi n, Rn, Sn, like this. We call it a Slate determinant. But unfortunately, there are so many electrons, and this exact solution of a Slate determinant cannot be possible, as you know. But it is just only the mathematical formalism, and mathematical formalism on the to consider for the exchange energy. That here we do not know that explicit form of the Hartree Fock wave function, total wave function, written by the Slate determinant. And anyway, and let's apply to the Hartree equation in this case, and the Hamiltonian expectation value with respect to this total wave function is that for summation for the electronic state and the dr psi ir and the kinetic energy h bar square over 2m delta square plus u ionic kinetic energy and electron ion interaction psi ir it is, and plus, and electron interaction is that 1/2 and 1/2 summation for ij integral dr prime r minus r prime e square psi ir square psi jr square, and minus it is subtract by the Pauli exclusion, and also here summation ij dr prime e square over r minus r prime. If the spin si and sj are identical with each other, and it is not permitted from the Pauli exclusion principle, therefore we should subtract psi I r star, psi I r prime, psi j r prime star, psi jr, and also I will describe for each part, and it is a kinetic energy plus electron-ion interaction, and this term is for the electron-electron interaction. When you consider only this term, it is the Hartree equation, but Hartree Fock equation is that subtract this term, because we should consider for the Pauli exclusion principle, subtract by Pauli exclusion principle, because same spin should be excluded. Therefore, from this point of view, this equation, the Hartree equation, can be modified as a Hartree Fock equation. Like this, minus h bar square over 2m del square psi I r plus u ion r psi I r plus u electron r psi I r, and minus, important thing is that the minus summation for j. Here we only consider for the ith atom, therefore here the summation only for summation for j. Here dr prime e square over r minus r prime psi j. Here psi I cannot exclude here, r prime psi I prime psi j r, so delta si sj equal to epsilon I psi I r. Anyway, this also has the iterative solution. In this iterative solution, psi j should be inserted as a trial wave function, and also by inserting this trial wave function, then by solving this equation, and the psi I can be obtained, and also iterative solution can be possible. And this is a basic idea how to calculate the exchange energy. And the detailed calculation for the detailed calculation like double exchange and super exchange and many exchange interaction based on this Hartree Fock equation. And anyway, and we from at this time we study for the basic concept of the interaction, and also in the next class we will deal with magnetic ordering like a ferromagnetic and antiferromagnetism.